Assalamualaikum. My name is Ilham Skandar. I'm going to explain question number one. Question one. An engineer is interested in testing the bias in the pH meter. Data are collected on the meter by measuring the pH of the natural substance, which is a pH equal to 7. A sample of the size 10 is taken with the result given by calculate the mean and standard deviation of the sample taken. Step, we have to find the mean. To find the mean, we need to use the mean formula. Mean equal to the sum of the data value divided by number of the sum data. Then put all the value that we have and divided by the number of the sum data. We will get the mean of 7.025. To find the standard deviation, we must find the variance first. The formula for the variance is 1 over n sum of fx square I minus fxi square over n, where n is the total number of the data point, si equal to each individual data point, and fxi square over n is the population mean. So put all the value given into the formula. You will get the variance of 0.001745. Using the calculated value of the variance, we can find the standard deviation. The formula for the standard deviation is square root of the variance. Put the value of the variance into the formula. The final answer for the standard deviation is 0.0418.
We move on to question 2. The question are, 3 cards are drawn in succession without replacement from an ordinary deck of 52 playing cards. Find the probability that the event A1 intersect A2 intersect A3 occurs, where A1 is the event that the first card is a red ace, A2 is the event that the second card is a 10 or a jack, and A3 is the event that the third card is greater than 3 but less than 7. Okay, so now to find the probability of the event A1, A2, A3, we need to consider the individual events, which is the A1, the first card drawn is a red ace, and A2, the second card drawn is a 10 or a jack, and A3, the third card drawn is greater than 3 but less than 7, which is it can be 4, 5, or 6. Next, the S is 4 cards, Jack 4 cards, 10 4 cards, which is the three of them is all 2 black and 2 red cards. So the total is 52 cards, which is 26 red and 26 black cards. So this is how to calculate and the answer. Step 1, we need to calculate the probability of A1. There are 2 red ace in the card is in the standard of card 52 cards. So the probability of drawing a red ace first is 2 over 52. Next, event P2. Once we have drawn a red ace, now there are now 51 cards remaining in the deck. The number of favorable outcome for event A2 is still 8, which is 4 tens and 4 jacks. Therefore, the probability of drawing a 10 or a jack after drawing a red ace is 8 over 51. Next, event A3. After drawing a red ace and then either a 10 or a jack, there are now 50 cards left in the deck. So the favorable outcome for event A3, drawing a card greater than 3 but less than 7, are the cards number 4, 5 and 6. There are a total of 12 such cards in the original deck, 3 cards for each rank. Thus, the probability of drawing either a 4, 5, 6 after having drawn a red ace, then a 10 or a jack is 12 over 50, which are the 3 times 4 over 50. So when we get the A1, A2, A3 event, we can now consider to multiply them, multiply the three of them. So we get the answer 8 over 5525. So that is the answer.
For question 3, a shipment of 8 similar microcomputers to a retail outlet contains 3 that are defective. If a company makes a random purchase of 2 of these microcomputers, find the probability distribution for the number of defective. So we will use the hypergeometric distribution, and the information that was given is n equal to 8 is the total number of items, d equal to 3 is the number of defective items, n minus d equal to 5 is the number of non-defective items, n equal to 2 is the sample size, k is the number of defective items in the sample. Now, let's calculate the probabilities for k equal to 0, 1, and 2. So the first case, k equal to 0, this means no defective microcomputer in the sample. Using the formula, we will get 5 over 14 equal to 0.3571. So the next case is k equal to 1. This means one defective microcomputer in the sample. We will use the formula and get the answer of 15 over 28 equal to 0.5357. And the last case is k equal to 2. This means both microcomputer in the sample are defective. And we will get the answer of 3 over 28, 0.1071. This shows the likelihood of selecting 0, 1, or 2 defective microcomputer when randomly picking 2 from the shipment.
Assalamualaikum. My name is Muhammad Lufiz Habib. I will continue with question 4. So for the question is, the probability that a patient recovers from a rare blood disease is zero point 0.4. If 15 people are known to have contracted with this disease, what is the probability that from 3 to 8 survive? So we have 15 patients and the chance of each one recovering is 40% or zero point 0.4. So we want to find the probability that between 3 and 8 this patient will survive. For this question, we can use the binomial probability formula for this. It helps us calculate the likelihood of a certain number of successes in a fixed number of trials. The formula that we will be used is NCX times P power of n times Q power of n minus x, where n is the total number of trials, x is the number of successes, p is the probability of success, and q is the probability of failure. So we will calculate the probabilities for 3 to 8 recoveries and then add them up with total the probability of 97.78%. So for the next question, 10 is the average number of oil tankers arriving each day at a certain port city. The facilities at the port can be handled at most 50 tankers per day. What is the probability that on the given day tankers have to be turned away? So for this question, we can see that on average, 10 oil tankers arrive each day. However, the facilities can only handle a maximum of 15 tankers per day. So the goal is to find the probability that on a given day there will be more than 50 tankers arriving, which means some will have to be turned away. Since we are dealing with arrivals that follow a Poisson distribution, we can use the Poisson probability formula to help us with this calculation. For Poisson formula, X represents the average number of arrivals, in our case 10 tankers. Mu is the actual number of arrivals and E is a constant, which is approximately equals to 2.71828. So we will add the values in the equation and get the answer, which is 3.47%.
Hi, my name is Muhammad Muizzuddin. Now I will explain how to solve question 6. So the question is, gush are used to reject all components where a certain dimension is not within the specification 1.5 plus minus r. It is known that this measurement is normally distributed with mean 1.5 and standard deviation zero point 0.2. Determine the value of R such the specification cover 95% of the measurement. Okay, first of all, for a 95% confidence interval, the area in the tail is 1 minus 0.95 equal to 0.05. Therefore, each tail contains 0.05 divided by 2 equal to 0.025. And based on the answer, which is 0.025, refer standard normal distribution tables to find the value of z. And the value of z is 1.96. Next, after we get the value of z, which is 1.96, we use the formula of z, which is x minus mean per standard deviation, which is when we put the information given in the question, we can get the value of r, which is we get 0.396.